Everyone, and thank you for joining us today for our Insulation Intel webinar, Insulating Combustible Pipes and Plenums. My name is Kim Melton, and I will be your moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost, we are working from home, so if we run into any problems during the presentation that are disruptive to the presentation itself, we'll pause for up to 5 minutes to see if we can correct it. If we can't correct it in that time, we will either re-record and send you the recording, or we will host a new presentation at a different date that we will send you an update on down the road. Also, we will be doing a live Q&A at the end of the webinar, so you should see a Q&A to the top right side of your screen. If you don't see that, in the bottom right corner is a small ellipsis. If you click on that, it'll open a Q&A dialog box that will open the Q&A feature to the right side of your screen that will allow you to submit questions, and we will address those questions at the end of the presentation. Also, today's webinar is for educational purposes only and should not be used as a substitute for professional engineering design, consultation, or documentation that might be required by the building codes, contracts, or applicable laws. If you have any questions about this or any of the products we've discussed today during the webinar, you can refer to our specific application guidelines and instructions located in the product sections of our website, or you can reach out to us directly and get some tech support with a live person at JM. Now, we're going to follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we've done today. You can use the survey to ask any additional questions that you may have on today's topic or even suggest new topics for future webinars. But this survey is part of how we deliver the JM experience to you. Now, the JM experience is based on 4 pillars of the JM culture, and you'll see those in the bottom left corner, and that's people, passion, perform, and protect. And for us to deliver this to you, we want to make sure that we're getting your feedback and providing the best interaction to you. And part of that is a two-way street in communication. So this survey really allows us to do that. And we use your feedback to improve our webinars and provide the information that has the most value to you in future webinars. Now, we're also frequently asked whether or not we send out these presentations upon their conclusion. And while we don't send out the presentation itself, we do post a recording of it online for you to watch at your leisure, or you can share it with your colleagues. This ensures that you can have the presentation within its full context, and we'll send you an email when it's live on our website. So with that, I'm going to hand it over to our hosts, Greg Newman from Insulation Midwest and Natalia Maximova from Johns Manville, to introduce themselves. So Greg, why don't you get us started with an introduction?
Greg Newman with Insulation Midwest. We are a design build insulation contractor, and we do everything from a Dairy Queen to a nuclear power plant.
Great. Thank you, Greg. And my name is Natalia Maximova. I'm a senior product engineer here at JM. I've been with the company for over 2 years, working on mechanical and industrial insulation. And now let's get started with focusing about the code. So the code and the testing will be a big topic for us today. So first of all, let's look at the plenum. So what is the plenum? All of the testing and certification that we've done was done for plenum. So the plenum is defined in the mechanical insulation code as an enclosed portion of the building structure other than an occupiable space being conditioned that is designed to allow air movement and thereby serve as part of an air distribution system. And we're looking at a typical picture of the plenum here. And as you can see, there's a number of utilities. We have plumbing, we have electrical conduits, we have some duct work, and that's what we'll be focusing on. I also would like to draw your attention to 2 points where the air movement and air distribution is mentioned in this definition, and this becomes important as we're considering the fire testing that we will discuss a little bit later in this presentation. So as mentioned in the plenum, you will have a number of utilities, and some of them will be pipes. So as in any situation, you should be insulating pipes in the plenum or otherwise, because insulation provides a number of benefits, and they are listed here. So it provides energy savings, process control. So if you are transferring cold or hot fluids through the plenum, you want to make sure that those fluids arrive at the correct temperature to where you need to use them. So related to the cold fluids, you would want to keep them cold and prevent condensation. Condensation can cause issues with just dripping water. And again, we do have electrical conduits and things like that. And if the condensation is not controlled, you can also have mold and fungi growth in the plenum space. For cold or other fluids, you really need to be protecting them also from frost, from cold temperatures. While the plenum space has the air movement with the occupiable and conditioned space, it's not fully conditioned, so you can have extreme temperatures in this environment. We want to also insulate pipes because certain types of insulation will provide the fire safety, so that will protect the combustibles from reaching high temperatures. So that's the fire safety benefit. And certain types of insulation provides acoustics benefits. So with the plenum spaces, oftentimes above occupiable spaces or offices, some of the pipes could be for rainwater, and as the rain is happening and then you have the rain rushing through the pipes, the occupants of the space do not want to hear that. So that's another huge benefit of the insulation. All right, so now let's talk a little bit more about the codes. So International Building Code gives the instructions and kind of controls on what should be used in the buildings. And when it comes to plenum, the building code refers us to the International Mechanical Code. And as any code, the codes are evolving, but in the last 3 revisions of the International Mechanical Code, it really has been the same verbiage that we see. And the International Mechanical Code specifies the following when it comes to the plenum: that materials exposed within plenums shall be non-combustible or shall be listed and labeled as having a flame spread index of not more than 25 and a smoke developed index of not more than 50 when tested in accordance with ASTM E84 or UL-723. So again, just to recap, so the plenums, only non-combustible or materials that are listed and labeled with flame spread and smoke developed of less than 2550. So that really limits of what can be used in plenums. There is, however, exception 5, which says that combustible materials fully enclosed within one of the following can be also used. And what are those exceptions? We have the first one, which is continuous non-combustible raceways or enclosures, approved gypsum board assemblies, or materials listed and labeled for installation within a plenum. So there's a few ways how combustible materials can be also used within the plenum. And again, why are we concerned about all of this? If you remember earlier in the definition for the plenum, the air is allowed to move between the plenum space and the occupiable space. And because of that, we really want to be very careful of what is allowed in that space to not have a fire hazard. So on this slide, there's 2 occasions where we have this listed and labeled mentioned. So some of you may be wondering, well, what does that mean? So it's actually quite intuitive. So for listed, this refers to the testing that was done by a third party, and this will come in the testing that is done on the equipment, products, or materials, and the third party needs to be recognized by code officials as the appropriate organization to conduct the testing. Other than initial testing, there would also be most likely follow-up testing, and that's to ensure that the materials and the products have not changed since the original tests were done. And the labeling, that's what it sounds. It's a labeling that will be on the packaging on the units that will indicate that this particular product has been tested. So that's what listing and labeling means. So as mentioned, that there's quite a bit of pipes that can be in the plenum space. So let's talk a little bit more about the pipes that may not be meeting the requirement of 2550. And there's actually quite a few pipes and a few uses for them. So most often, the combustible pipes will be used for rain drains, domestic hot and cold water Also the waste and vents. And the materials most often used are PVC, CPVC, high-density polyethylene, polypropylene or cross-linked polypropylene, so that's PPR, as well as the ABS piping. So from the high level with these pipes in the plenum potentially, why would we need to protect them? So again, because there's an air movement between the plenum space and the occupiable space, we really want to give the occupants time to egress in case of the fire. So by having the combustible pipes protected and limiting combustibles, that's how we will achieve that. Also, since the utilities are running through these pipes, we want to minimize any damage to them, because that will protect really the building structure and usability. Because you can imagine that it will cost substantial resources if the pipes will need to be replaced after the fire. And by protecting the pipes, we are reducing fuel available for the fire. So these are all the good reasons for why the code kind of tells us that the combustible materials need to be fully enclosed. So also in the code, we talked about the ASTM E84. So this is a main test method that is used extensively in the building as well as the mechanical installation industry. So now let's talk a little bit about that, because again, this is the test method that is used to assess and get that listing and labeling. So ASTM E84 is the flame and smoke tunnel test, and that is used to determine the surface burning characteristics. E84 is essentially identical to the UL-723, so they can be used interchangeably. And just to remind you, per code, the Plenum requirement is that the flame spread index needs to be less than 25, and the smoke developed index needs to be less than 50. And now if we look at this picture, this is actually us looking at the tunnel, and we're looking at the burner. So the burner has the natural gas, and the insulation will be installed on the top of the tunnel. So that would be, if you think of mimicking, in case you have like a wastebasket fire, and then the flames are coming up. So the insulation will be installed with a surface that will be facing the flames. So in our case, for pipe insulation, we will be installing with it facing down. So let's have a look at the other picture of the tunnel. So now we're looking externally, and this is the tunnel that we have at our research facility. It's a large-scale test. So the length of the specimens that will be installed in this tunnel are 2 feet by 24 feet. Obviously, it can be hard to get such a long pieces, so we can use sections of it. And that's basically what we've been doing for this testing, especially if you know that our pipe insulation comes in 3-foot sections. So those are the sections that we've had installed in the tunnel. And so you could see that the tunnel, and from the previous picture, the insulation is tested in the flat configuration. And obviously the pipes are round, so how do we do that? There's a procedure, ASTM E8231, which tells us how to produce test specimen specifically for this test so that it's representative of the pipe insulation. So you can really think of it as a flattened, kind of squished pipe insulation. The tunnel is calibrated, and the insulation is installed on the top of the tunnel. So again, the flames will come from the bottom. And the facing, if in our case we were testing with facing, it will be exposed to the flames. So that's going to be pointing down. And the duration of the whole test is 10 minutes. So again, it's a large-scale test, relatively long period of time if you think about that. And we'll look a little bit more of how actually the test and how the sample looks like before and after the testing. So 2550, we keep talking about that. And so what does that mean? What units is that? So the 2550 fire hazard classification is determined by comparing test materials to the flame spread and smoke developed index for the 3 calibration materials. This is a relative measure. It's not absolute. It's index that tells us like how we're performing compared to the standards. And the calibration materials that we use are incombustible cement board. So as stated, it's incombustible. So this material that will be given this flame spread index of 0. So the flame will not be spreading on this material. And the smoke develops 0 index of 0 as well. So this material will not be given any smoke. For the other extreme on the flame spread, we have combustible red oak. So it is combustible, and that is given the index of 100. So when we are calibrating for red oak, we want to see the flame spread the length of the tunnel very fast. So within 5.5 minutes plus or minus 15 seconds, the flame needs to travel all the way through. So that's our extreme of combustible material, just to give you kind of an idea what we're talking about. And for the smoke, we use heptane. In the previous revisions of ASTM 84, it was red oak was used, but in the most recent, it was switched to heptane because it's more reproducible. As you can imagine, red oak is a natural material, so there could be some variability from it. And so now we're using heptane. So now let's think about, okay, so how do we interpret these results? So for flame spread, we are talking about evaluation of how quickly the flame spreads over a specific period of time as compared to the red oak calibration standard. So for flame spread, we have two elements. We have the time and we have the distance. So the further and the faster it goes through, the higher basically the numbers would be. So the number of 25 is relatively low because if you remember, red oak is 100 and it spreads over the tunnel in roughly half of the duration of the test. Smoke index, that's evaluated by the smoke density at the end of the tunnel, and we're measuring that by light penetration. And during the entire test, what we're doing is that we are building this curve. We're measuring the smoke density over the entire 10 minutes. And then after the test, we will determine what's the area under the curve and compare it to the calibration. So when we say in about, okay, the smoke developed index of 50, that tells us that's 50% of the smoke density of heptane over the same period of time. And now we're going to switch gears and talk about the testing that we have done at UL to get the listing that we are discussing here. Okay. So for the test conditions, they're listed here. So now that we understand a little bit more of how the tunnel is set up, so you could see that we had the flames kind of on the bottom, and then it was insulation, which we've tested Microlock HP and Microlock HP Ultra. It was always 1 inch of fiberglass with different facing. And then we've used two substrates. One was the 1/2 inch PVC, and the other one was 1.5 inches of PPR or polypropylene. So, so these were configurations, and both were tested again with Microlock HP and Microlock HP Ultra. So as you could see, the PVC and PPR thicknesses were different, and you may wonder why is that. So the difference in thicknesses is because, as some of you would know who deal with pipe, you know that as the pipe diameter increases, the wall thickness increases as well. And so when we check on the Schedule 40 PVC pipes, we found that essentially pipe diameters up to 16 inches, actually including 16 inches, the wall thickness will not exceed 1/2 inch of 1/2 inch, and that's why we selected it. And similarly for PPR, there's a little bit of more of a difference in the thicknesses, and we went with 1.5 inches. So in general, you would not have to worry about, well, what do we test for? As long as you're using pipe diameters of 16 inches or lower, you will be fine because we've tested it. And again, why do we go with the thicker as opposed to thinner? Because both materials are combustible. By putting the thicker material, we're technically testing the worst case scenario because that's the most fuel for the fire. So again, that was the selection of why we went with the thicker boards for these testing. And now let's let's look at the pictures and get a little bit more kind of closer to the test. Less theory, more practice here. All right, so now we're looking at the board here, and this is looking at the facing of the boards that we've used for testing. So it was constructed with 1 inch of microlock board. Then we have the facing. The facing is actually in 2 sections with the SSL in the middle joining it. So you may be a little hard to see, but there's an SSL tape in the middle. There's also adhesive. So those of you who deal with Microlock HP or Microlock HP Ultra, you know that we have hot melt adhesive installed on either end of the slit. And so that's the same way we're testing it here. So it's really a flattened version of the pipe insulation. The staples are installed here just because, unlike in the pipe configuration where there's some tension, here the facing would just fall off if we were to flip it over for testing. And everything here, like I mentioned, the boards, where the SSL goes, the adhesive and the staples, all of that is specified. So it's very prescriptive as to what goes into the tunnel. All right, so now we're looking at the test. So the tunnel test is done. The E84 test is done actually in the dark because this way we can track the progress of the fire through the tunnel. And we're looking roughly kind of in the middle of the test. I wish I could show you the video, but it's just does not work very well with WebEx. So we're looking at the picture here where the flames, this is a natural gas, and we're looking at the area where the burner is. And it is actually quite exciting for those of you who enjoy the fires. It's generally, the flame does not really propagate too far, especially for materials that have the 2550 rating. So now that we looked at the tunnel, let's have a look at what the insulation looks like after we pull it out. So here we pulled out insulation, we flipped it over, so we're looking at the side that it has been facing the flames. And the entire tunnel is kind of laid out in this long table. And the closest board to us is the one that was over the burner. This is where we saw all of those flames. And you could see that the facing was damaged and on the first 2 boards, but then after that you kind of have charring, and kind of the furthest boards just have a little bit of soot on them and not much else. So yeah, so the flames were really quite strong here. You could see there was a little bit of discoloration on the fiberglass as well, which is quite common. So now you may be wondering, well, what happened to the combustible substrate that was right over it? And we've seen the raging flames. We obviously see that insulation has been exposed to flames. Well, now here on this picture, we could see that the substrate, and we're specifically looking at the PPR here, has been hardly affected. We see some discoloration. It started off, completely white, and now we have a little bit of yellowing, and there was some minimal amount of melting kind of right over the burner, and then after that is just really kind of almost like virgin boards as if nothing happened. So what this tells us is that just 1 inch of insulation of Microlock HP or Microlock HP Ultra really protects the boards quite effectively. And again, we're looking at the PPR here. So these pictures were taken at our facility, but we've done this testing, and actually everything was done in triplicate also at UL. So as a result of all of this testing, we have the third-party verified test results for Microlock HP and Microlock HP Ultra. And so now they're approved to use over combustible pipes, PVC or PPR in the Plenum space. And also, again, just to mention to you that we have tested a really extreme, a very conservative scenario by testing very thick boards of PVC and PPR. And I also want to point out that Johns Manville manufactures Microlock HP and Microlock HP Ultra in 1/2 inch wall thickness as well. If you're using it on Plenum, the wall thickness has to be 1 inch or thicker because that's what was tested here. So even though we do sell 1/2 inch, that will not be good enough for the Plenum space because that's not what we have listed If you need to install thicker microlock HP or microlock HP Ultra, that's not a problem. You just cannot go less than 1 inch, and that's very important to note. And now I'll be wrapping up with some of the common questions that we usually hear about the 2550 fire rating. The first one, why did we retest microlock HP and microlock HP Ultra? Some of you may be familiar that we've actually done a third-party testing back in 2015, and we did get the 2550 rating, so that was all good. And but in 2020, what we've done, we went and we got through the whole process of listing and labeling, because in 2015, which is the testing, and now what we've done, we had UL audit the entire process from procuring to producing sample boards, and then all of this was tested at the UL facility. Also, they collected some samples of like hot melt adhesive and things like that, so they have those examples on file. And as a result, we have the listing and labeling for the BSMP, which is the insulated plastic pipe assemblies category. And our packaging will be labeled with 2550 specific to this, to the testing that we just shared with you. We're in the process of revising packaging right now. The next question we get is that why is the third-party testing so important? There are a few reasons for it. First of all is that the test samples are audited to make sure that the material is representative. So again, it gives everybody confidence about the fact that what was tested is actually what would be used. The next one, it removes the risks of biased testing and reporting, because again, it's done by third party. And also it ensures that the testing and reporting is consistent, fair, and accurate, because these third parties, they test all sorts of products, all sorts of materials by Johns Manville and by competitors and anywhere in between. And finally, the last question is the 2550 the same as hourly fire rating? And the answer is no, it's not. The hourly rating is a different test with a different outcomes. There we're looking not for materials just not burn, but there we're looking for how the materials withstand the flames for multiple hours. And there's specific criteria. And here we have a listing for some of these tests that can be done to get the hourly rating. But the short answer is that the 2550 and hourly rating, they're two different things. And with this, I'm going to turn it over to Greg for additional information on practical applications.
Thank you, Natalia. Let's see here. I got to get my stuff up there. All right. We are seeing in the industry a growing trend towards plastic pipes. We all know that the steel pipe industry is going through the roof. So we need to keep building buildings, and we need to keep coming up with products. But as you know, the plastic pipes do not have a 2550 fire rating. So we've done quite a few projects with John Mansville where we had to come up with alternative methods. So what we did is the first one was a stadium here in Minnesota that they ran a green pipe that was for acid waste, for cleaning kitchen floors, degreasing. So, but all the air handling units, the rooms themselves were return plenums. And that's where a lot of these drains were. So the fire inspector for the city of Minneapolis would not allow them to do that. So we, with JM's help, come up with the rating. We got the letters, they did the testing, and we could insulate it with the HP and fittings included on this job. So we did that. Now, over the many years since we've done that, there's many other facilities, laboratories. I remember back in the day, the drain lines in laboratories were made out of glass because the plastic pipes weren't yet available for these acid waste or anything that would eat, the pipes. Couldn't use iron pipe. Acids would eat that. So they come up with the plastic. Now, we are running in a lot of this where out east, they wanted soundproofing. We all know that metal gives off a lot of sound. So what we did is we did up a letter with John Mansville that if they did the pipe in plastic for these drain lines, it would quiet. So we put the 1-inch insulation and cured their problem. Took care of the 2550 for them. So now when you guys are designing the piping systems, you need to treat these systems like they're chilled water. Everything has to be on the outside of the insulation. Everything, hangers, all of it. Saddles got to be on the outside. Nothing can be on the inside, you know, that is on the outside of the covering, like the hangers. So everything has to be internal, 100% all the way down. But it can be done, so no problem. Fiberglass. The 2550, when you do that, you know, it's like Natalia says, totally different than Plenum wrap. Plenum wrap will give you a hourly or 2-hourly rating of transference of fire through a mechanical system. That's why you have fire and smoke dampers and ductwork. That's why we do fire wrap on ductwork that is supplying an area that is subject to fire, so you can't transfer it. So piping is the same way. Anything that can transfer the flame spread from one room to the other, whether it's 1 hour or 2 hour, needs plenum wrap. But if you're running plastic pipe, you can use it for DI water or RO water instead of stainless steel. You put the HP Ultra on there and you can continue. Now you got your 2550 rating and using plastic pipes, which is a big benefit, especially with the price of stainless steel going up. Now the installation, when you guys are looking at the installation out there, it's just like chilled water. Your laps, you got SSL, needs to be put down, sealed, stapled. On the laps themselves, the same thing. You lay them down, you rub them down, and then you staple them. Now, we're not worried about any chilled water or any heating medium transfer. So all we're looking for is the 2550. So which you will have with this.
All right, thank you very much, Greg. So I do want to talk about additional resources and where they are located so that you can find them on the JM website. All of our educational content is located on the source, and this is a one-stop repository for all of the information that we have from our recorded webinars to specification information. It's where you can find our latest blogs, details about each of our products, specific tools that can help you, like the Smart Binder app, which is a tool you can download it directly to your phone and access immediately any JM collateral that's of value to use, whether that's data sheets or safety data sheets. And then there's also online training for anybody looking for mechanical or HVAC training. And we do have a source available for our HVAC, industrial, and building insulation businesses. So if you have any information or need any information, we recommend that you go find that there. Additionally, we will be following up today's webinar with a certificate of completion. This webinar will be sent to your inbox by next Wednesday, so please keep an eye out for that. And we will also include, not in the same email, but in a separate email, we'll include a link to the recorded webinar of today's presentation. So with that, we're going to start with some questions and put Natalia and Greg in the hot seat right now. So let's start with our first question. And Natalia, I'm going to turn this one to you. And Greg, if you have anything to add, please feel free to do so. So Natalia, what domestic water pipe fitting insulation products are Plenum rated? In particular, fittings, as the PVC products don't appear to be Plenum rated. And then is the resin used also Plenum rated?
You know what, that's a good question. So I'm going to interpret this with this, the PVC, we're talking about the PVC jacketing that is used, like the Zeston PVC jacketing for this one. So Zeston PVC jacketing has been third-party tested, and it does have the flame spread smoke developed of 2550. However, we have not tested in this particular situation with UL, so we do not have the UL listing and labeling for it. However, I think Greg has some suggestions on ways around the fittings and elbows.
Yeah, we've had this complication, especially on some of the stadiums where we had to have John Mansville do a third-party testing for that particular product with the Zest on fittings. All of the ones that we have required, we have gotten a third-party letter and we could do it. So you also have mitering. You got an option. Now you can continue that HP Ultra or ASJ and just miter your fittings, and that will give you your 2550 also.
All right, thank
Okay.
you, Greg.
Yep.
So the next question we have is for you, Natalia, and that is, are California codes more restrictive?
When it comes to the fire ratings and the plenum usage, no, International Mechanical Code and the exception 5 that are covered applies to it because it's national. If this person is asking about other types of other parts of the code, then it could be different, and they are welcome to call our technical line, and we can jump into it and help them answer that question. But again, when it comes to the fire rating, it's 2550 International Mechanical Code.
All right, thank you. So the next question is, where can I find a comprehensive list of combustible materials? And Natalia, I'll start with you. Greg, if you have anything to add to that, please feel free to jump in once she's complete.
Okay.
Comprehensive list of combustible materials. I'm not even sure where we would start. I mean, we've mentioned a number of the combustible materials that we would usually encounter in Plenum. We talked about the ABS. We talked about high-density polyethylene, PPR. You can also see PEX, which is cross-linked polyethylene. Yeah. Greg, any other ideas for combustible materials?
Yeah, any products that you're going to plan on using or want to use, they all have data sheets. And on these data sheets, I'll tell you if it's 2550, if you can use it in a plenum rated or not. And, you know, if you want to use it, then you can contact your John Mansville rep and then get the 2550 on there on the product. But all products on every job has data sheets, and we have to do them on submittals for every job, so they're there. Okay.
All right, thank you both. Natalia, the next question is fiberglass insulation over PVC waste piping in a return air plenum acceptable per the code?
Yes, it would be just like we've discussed here. So the PVC waste pipe, as long as it's using the material that has been listed and labeled, as discussed earlier, with a 2550 rating for the usage over the plastic pipe assemblies, that would certainly be acceptable per the code under that exception 5.
All right, thank you. Greg, the next question is for you, and that is there a spot on the submittal sheet that says listed and labeled for use in plenums over PVC and PPR piping?
No, that would be a direct submittal for that type of product for that situation. That would be a line item on that submittal, what I meant. So you can do that, 2550, you put it in your submittal, this will cover, you know, your plenum rating. So yeah. We do those submittals all the time like that.
All right, thank you. Can you, Greg, this next question is for you, and then Natalia, if you have anything to add, please do so. And it is, please clarify the installation of pipe hangers to maintain the fire rating. Can the typical thermal block and hangers be outside the insulation, or do they also need to be internal to the insulation and the jacketing?
Hangers need to be on the outside. Everything, that pipe has to be 100% sealed within that insulation. all the way through. So all hangers need to be on the outside. Treat it like chilled water. Okay.
All right, thank you. Natalia, this question is for you, and that is, must the IMC be imposed by a client in each construction, or is it automatically required by federal or state code legislation?
You know what? That's a good question. I think we usually kind of get it on the back end when the inquiries are when somebody already required it. Greg, you may know. I would imagine that it's the architects or engineers who design in the building. Where do you usually encounter that piece?
Usually the engine, well, the architect and the engineer, when they're doing their layouts, they don't want to, it's like using DI water, DI water is usually with stainless steel, but a lot of people are using plastic pipe now. It's cheaper, easier, and as you know, the metal prices are going through the roof. So this gives people an option that they can continue with that pipe, go through one area that is not requiring 2550, but go through another area that requires it. And you can continuous with the same pipe.
All right, thank you. The next question, Natalia, this is for you, and we might need to circle back on this one, but is this product approved for S102 for Canada?
You know what, I'll have to look at our data sheet. Yeah, I'm pretty sure that we have the S102 on our data sheet. Let me quickly look at it because, yeah, actually, yeah, we do have the S102.
Okay, perfect. The next question is, who do we contact for Canada sales? Whoever submitted this question, I've taken a note, and I will have our Canadian sales reps reach out to you directly. So Natalia, since you're looking at the data sheet, what is the K factor for microlock at 32 degrees Fahrenheit?
32 degrees Fahrenheit. So that is technically not requirement to be tested. So we have the requirements to go from, I think, you know what, I'll have to look at the ASTM standard because on the data sheet we have 75F, but I think we do have data for 25 as well.
All right, I'll take a note and we can follow up with that person. The next question is, Natalia, if you'll start with us, and then Greg, if you have anything to add. Can a PVC pipe that does not have to be insulated be wrapped with foil, which has a 0-0 flame smoke spread, to meet the code?
Okay, so if I'm understanding correctly, this individual wants to basically modify the material so that in case of the fire, the flames will be hitting the foil. It will depend really on a lot of situations, like how thick is the foil. But the whole point is of conducting the testing, and that's what we went through this. And it was an effort, let me tell you, is because it's a true test where you are, where we evaluating how the flame is interacting with the material and the substrates of the PVC in this case. So again, it will depend on so many things. As long as the foil has been specifically tested and listed and labeled, then sure, it would apply, but just arbitrarily picking up the foil and wrapping it around, that will not be acceptable because, again, it's listing and labeling. That's where the issue is.
Thank you very much. The next question, there seems to be some confusion about whether there's a standard insulation and a 2550 rated product. Natalia, can you speak to the product offering and how they meet 2550?
Sure, yeah. So this is all of the testing that we've done, it covers the standard Microlock HP and Microlock HP Ultra. So what was done here is specific to the scenario of testing with this combustible substrate. So it's not anything different. It's the same formulation, same thermal performance, same jacketing as a standard material. It is just something that now we have this third-party verification, listing, and labeling that we've acquired for our standard product. Again, Microlock HP and Microlock HP Ultra. And it will be labeled on the cartons You would not have to be sourcing and stocking regular material in 2550, because also many of you probably know that the Microlock HP already have the 2550 rating. It just, this was done specifically tested as an assembly with that plastic, not just by itself. So hopefully that answers the question.
I think it does. So Natalia, I'm going to start with you on this one, and then Greg, if you have anything to add, please do so. And that was, previously we had an issue with a water heater located in a plenum that the inspector required a 2550 rating for the water heater. Is there a product that GM has to offer that could have insulated this water heater?
Well, I mean, we have
Was it an
plenty of
electric water
products
heater?
that have, yeah.
It doesn't specify what type of water heater it was, but Natalia, if you could highlight a couple of the products that JM has to offer that could have been used on this water heater, that would be good.
I mean, it will depend on how much insulation they really will be looking at, but most of the materials, like any kind of FSK, I mean, again, I wouldn't use probably pipe insulation, but any FSK, probably blanket type of insulation or ASJ would be probably applicable. Greg, what would you use? Because all of those are 2550 rated.
You know, a water heater, is it electric water heater? What's your combustion source? If it's a gas water heater, no, you need to move it. You can't have that in return plenum, gas or flames. Boiler rooms are generally not a 2550. So to maintain that, you'd have to, well, you couldn't return that anyhow. So I don't know why there'd be a 25, why the inspector would want a 2550. You can't return that mechanical room. So something
All
that
right.
something needs to be moved.
Okay. Good to
It
know.
could be a good technical question where we can kind of dig in a little bit more detail. Sometimes, you know, it's hard for us to answer without additional information, but
Sure.
we have a technical line with great resources.
Yep, I'll take a note for us to follow up with that person. Greg, I'm going to send this next one to you, and that is the piping above a drop ceiling in a school hallway designated a plenum?
Is it ducted return or open return? Ducted return? No, it's not. Open return going to a air handler or even a rooftop, then that would be a plenum ceiling. Then everything in that plenum would have to be done.
All right. The next question is also for you, Greg, and that is, if the hangers are installed on the outside of the insulation, how do you create a fixed point to control expansion?
You would only have to worry about fixed point on expansion for hot water heat. That would be governed by your expansion loops anyhow. So that would take care of that. You can do fixed. You can have metal in there all you want. And that'll give you your 2550 if you did everything in the HP Ultra.
All right. The next question refers to your stadium example, Greg, and that is, was the referenced, quote, green pipe PPR that was used for the acidic waste?
Yes.
All right.
Suppose.
And then we have one more question, Natalia, and that is, if the plenum has a sprinkler system, does this still apply?
I think that per code, we still need to have the non-combustibles. We still need to have combustibles covered, as specified in that exception. We could certainly revisit that in detail. But yeah.
All righty. Greg, do you have anything else to add?
That's it. Good job.
Okay. All right, perfect. Well, thank you both for your time today. That wraps up all the questions we have here. And then there are a couple questions that we will follow up with people independently on. If there's anything that you didn't have answered that you would like us to answer, or if you have any additional questions that come to mind after this, I'd strongly encourage you to submit those questions in our survey, and then we'll reach out to you directly with the answers to your questions. So otherwise, Greg and Natalia, thank you for your time, and everyone else, stay safe and enjoy the rest of your week.
Thank you. Have a great day.